This is the atomic structure and chemical bonding. Second unit exam, actually, isn't it? So I have included the unit 1 content as well, unit 2 content included here. So we'll try to discuss one by one. The statement, no orbital can accommodate more than 2 electrons, is the principle of what is that? Actually, you had to remember that when electrons are filling in the orbitals, there are some principles govern the filling order, right? How it fills, what is the method of filling. So these are some Pauli's exclusion principle, Hund's rule, as well Aufbau principle. These are the 3 principles available in the textbook. So you have to remember what it means, right? What is the meaning of these right? How we can explain these issues. Regarding the Pauli exclusion principle, there are 2 content available in the resource book. One is the this principle states that no 2 electron in an atom can have the same set of 4 quantum numbers, right? It is very clear for us. Okay. It is very clear. Okay, right? For any kind of electron, you can use quantum numbers N, L, ML, and MS in it. Some address you can edit, right? Each electron having its own address, so certain set of quantum numbers. 2 electron cannot have same quantum numbers. That is some kind of principle. 2 electron can have n same value, same n value, same L value, same ML value, but in MS value it may be differ. One if it is plus half, then other one minus half. In this way, you can denote the quantum numbers, right? So the message is what? No 2 electrons in an atom can have the same set of 4 quantum numbers. Okay, that is one way of expressing the idea. In the old resource book, I have come across certain other information. Even it is also there in the new past paper, new resource book. This principle states that no orbital can accommodate more than 2 electrons. Is another way of explaining the Pauli exclusion principle, right? So within bracket, they also mention in the other word the set of quantum numbers. The set of quantum numbers for electron, for certain electron, an atom is exclusive for it, or no 2 electrons in an atom can have the same set of quantum numbers. So this is we call exclusive principle. Actually, the same thing here mentioned. So the answer is first answer, isn't it? First answer. Let's think about the Hund's rule as well, the Aufbau principles. Let's try to consider now. Yes, you have to really, remember this kind of work. Aufbau principle is some kind of building of electron, isn't it? The filling of electron in an atom begins with the subshell lowest energy, right? 1s, then it will go to the 2s, then it will go to 2p, 3s. In this way, shell lowest, right? Lowest energy and continues upward according to the Aufbau principle. This is a Greek term, building up, right? Building up, that's the term meaning of this principle. So lowest energy, electron filling the order, lowest energy to highest. So this is we call Aufbau principle. The Hund's rule, what it state? Actually, I had to remember when you come to the p orbital, first it will filling in the parallel, then it will go to the other way, right? Opposite direction, right? This is the way you have to fill it. In this way, right? If you needed 4 electron, you can't fill it in this way. This is unstable, right? According to Hund's rule, this is unstable. This is the most stable electron configuration, these 2, right? So what it states? Hund's rule states that for degenerated orbitals, right? Degenerated mean px, 2px, 2py, 2pz. When you come to these three orbitals, this is the way you have to write. Hund's rule states that for degenerate orbitals, the lowest energy is attained, lowest energy, that is more stable, no? According to some theories, if it is the lowest energy, it is the highly stable. Highest energy mean less stable. So lowest energy is attained when the number of electrons having the same spin. This we call same spin, right? Then only the opposite spin comes, right? Same spin is maximized. Okay, this is the way you have to understand. So why it undergo in this way filling order? Same spin, then in an opposite direction, right? To get a maximum stability. So with the lowest energy, right? That is the answer for it. So we clearly understood the answer for the first part. Let's come to the second question. What is that? The set of quantum numbers of 4 electrons in an atom given below, indicated as 1, 2, 3, and 4, right? It is clearly mentioned. By observing this configuration, you may able to catch the proper orbitals, right? This indicate an electron, isn't it? It indicates an electron. Right. It is fourth energy level, isn't it? 4. Main energy level is 4. 1 mean it indicate the orbit means sub energy level. Then 4p. 4p is the right electron. What is found in the 4p is mentioned here. Right? 4p is mentioned here. Here also 4 is, isn't it? This one indicate the sub energy level. Then 0 mean 1 is 0 is s orbital. This one p. This way you can continue, isn't it? This one d. So this talking about 4s is very clear. When you come to third electron, where it located, right? Starting from 3, 2 mean it mention the d orbital, right? The electron found in the 3d orbital is mentioned here. This fourth electron is also found in the third energy level, main energy level. Then it indicate the p orbital, right? P orbital. So now what they're asking is the set of quantum numbers of 4 electrons in the given below, indicated as 1, 2, 3, 4. Actually, what we have to find it, the energy of electron increasing. You have to think about increasing in the order, energy increasing order. Right, we have idea about this 4s2, Senate 4s2, 3d 10, then 4p 6, right? Before this 3p6, 3p 4 3d 10, 4p, and this things move, isn't it? So 4p is present here, right? That only having large energy, isn't it? One should be large energy. Then 3d, you have to think about 3d, that is mentioned in third position. Okay. Then you have to think about 4s, this one that is found in second place. Okay. Then finally, right, okay, 4s, and you have to remember that 3p, isn't it? 3p, it is found in the fourth place. 4, 2, 3, 1. This is the order. This is the order 4, 2, 3, 1. Then how are you going to 4, 2, 3, 1? 4, 2, 3, 1. I think answers available. 4, 2, 3, 1, right? You may mark, right, in the sheet. Okay, 4, 2, 3, 1 is the order. Okay, now, right, we'll try to think about the third question. The scientist who introduced the concept of energy level, right, and energy level. Actually, the certain these are scientists, right? Thomson, Board, Senate, Thomson, Board, and what do you call Rutherford. These people are the people, Marsden, right? Not Bagwell. These 4 people somehow involved in the atomic structure. Atomic structure, they propose certain people like Board proposed atomic model, Rutherford proposed atomic model, isn't it? Even supported by Marsden. Rutherford's work is supported by Marsden. Okay. Regarding the energy, the term energy, quantum numbers, energy is associated. So the term energy, right? When you come to Rutherford, electrons are revolving around the nucleus, isn't it? Like a planet, planets revolving around the sun. There's some kind of the revolving process occurs. Okay, but they didn't mention anything about the energy related issue. The person Bohr, Neil Bohr, is the person actually he used the concept, right? He know mean right Planck's constant or Planck work, Max Planck's work is understood by Neil Bohr, right? Those days they learn about this content, and he used the quantum numbers for his atomic model, right? Atomic numbers, the principal quantum numbers are used by Neil Bohr, right? Principal quantum number. Electrons are around the nucleus, revolving in a defined energy levels. Right, in this way, he mentioned right regarding the atomic model proposed by Neil Bohr. He used even the hydrogen spectrum, isn't it? Spectrum is used. He explained the hydrogen spectrum using atomic model. Okay, right. I think you may understood. The answer is Neil Bohr. When you come to question number 4, and what is the question? Which of the following ion possesses the highest polarizing power? Highest polarizing power. I think you may know that two terms are there. One, the polarizing power, then second one, polarizability. Polarizability. Right, this is related to anions, isn't it? Anion, how much it distort because of cation. That is we call polarizability. Okay. Here we are talking about polarizing power. Polarizing power related to cations. So answer should be third or fourth, isn't it? Other two or three elements mean ions are anions, right? When you come to here, lithium, the configuration is 2. Here it is 2, 8. But right, when you compare these two, there is an issue actually. Here 13 protons are there, just 3 protons are there, right? Okay, but this one, right, is the smallest, right? In two ways to supports. One is the size. Secondly, even the charge, right? So we call charge over size, right? This is mean 3 plus over size. Okay, then 1 plus over size, right? Sometimes these two may be almost equal in size. We don't know, right? We have to find it, but it is highly supported by the charges. Charge density is high. What do you call charge density, right? When you come to right the discussion, we had to think charge density, the term they used, charge density, right? Charge over volume size is higher for Al3 plus, therefore polarizing power of aluminium is higher compared to the lithium 3 plus, right? In another session, we'll try to think about the size of these two, how we can compare, right? Okay, next question related to okay, what is that? Atomic spectrum, isn't it? Atomic spectrum. It is actually found in old past paper. Just I have altered certain content. Okay, we'll see what is the answer with this. The false statement given by a student regarding the hydrogen atomic spectrum is okay. The main lines appear in the Balmer series are named as alpha, beta, gamma, and delta. Actually, in those days, these are the 3 things they used. Nowadays, right, even they have, right, included this one also in the resource book or the content. So we had to say it is correct then, isn't it? The answer is correct. We had to find it false statement. right? Remember, we had to mark the whole statement, isn't it? False. So this is the question part, right? Now let's think about second one. Every line in the spectrum, every line, what is that? You have a line, isn't it? Okay, right. These are some kind of spectrum, right? Color. Okay, this is a different, right? Sometimes red, some colors will be there. What about this line, right? What is that line? I think it is very clear for us. In this way, we can mark it, right? After transition of one electron from certain energy level, n is equal to 1, n is equal to, right? If it return from n is equal to n is equal to 1, n is equal to 2 to n is equal to 1, it will emit certain amount of energy, isn't it? Absorbed energy is emitted. What happens then? It is very clear, right? Okay, so every line, they are talking about these lines, every line in the spectrum is correspond to a specific radian. Yes, it is true, right? This is related to certain radiation. So that statement is correct. Lines appear in the visible region is named as Balmer series. Yes, this is the person who explained the content. Therefore, right, we can say that is true. The answer is correct. Answer is correct. Fashion series, right? Fashion series found in UV region. Actually, it has to, they're in the ultraviolet, so IR region, isn't it? IR region. IR region. So that answer is wrong. The reason for the spectrum is the transformation of electron between energy level. Yes, definitely. So it is not that much difficult thing. Easily you can find the answers, right? I think no problems for you. Now let's talk about the next question. Which of the following patterns corresponds most closely with the position of line of the spectrum of atomic hydrogen, right? Okay, right. How can you identify the correct one, right? I think you may able to find the most incorrect one quickly, right? Incorrect, right? So here the pattern totally in this side, this pattern is in this side. In this way, that there is no possibility of having in a diagram, right? So it is wrong. Here also, right, increasing direction here to here. So this also you can cancel. Furthermore, if you go to third one here, the mean gaps between lines are equal, right? It's impossible. So you can cancel the diagram. Right. When you come to fourth and fifth, what is the message? How can we identify the things, right? Okay, both are seems to be correct. How do you going to select the correct one? All right. Either you can select one of this. You can select one of this to answer the question. In this direction, right? In this direction, you can clearly see energy increases. Energy increases right, the pattern. By observing the pattern, you can see the lines between gaps between lines are shrinking. Therefore, energy increases. So say this one is the X series, or just say it is a Balmer series. Okay, just we'll say it is the Balmer series. So there should be another series found here, which is higher energy compared to Balmer. So it should be Lyman. Once again, I repeat the content. What is that? Consider this is a Balmer series. In this direction, energy or frequency increasing. Okay, frequency or energy increases, right? If you want to select then another series left to this particular series, if it is a Balmer series, so high energy series should be here, right? Then you can mark it as a Lyman. How to differentiate the Balmer series and Lyman series? There is a way, right? Lines, gaps between lines should be higher in the Lyman series compared to Balmer series. gaps between line should higher, right, in the Lyman series compared to Palmer series. So it is not there, right? You can't see that such a pattern here. So both cannot be the answer. Yeah, it is correct. Increasing, energy increasing. High energy should be in high energy series compared to the first series. This one, second one. Okay, this particular graph perfectly matching with our idea. I think you may got it correctly. If you have any issues, you can speak. No problem, right? Okay, the answer is fifth one. Now let's go to the uh, next seventh question, right? Seventh question example. Which of the following element has the highest circumambulation energy? Okay, very simple, direct forward question. Always you have to think about, right? Circumambulation energy, second one is difficult for first group elements, first group element. Third is difficult for second. Fourth is difficult for, right? You know that 13. This way you can, yes, predict, isn't it? It means you can easily remove one electron from lithium, but it is difficult. Why inner orbital? You have to go to inner orbital to right, remove the electron. That is why second group element having high energy. Second group element shows higher second ionization energy. So that is a way you have to understand. If you have any difficulty, you have to talk. Right, that is the answer. When you come to the eighth question, the process could be accompanied when vaporization of CH2 F2 from its liquid phase. Then how do you can understand, right? What is the molecule this? What is this molecule? We'll try. Okay. How do you going to write? There are two hydrogen. We don't know how it is located. Just we can mark it in this view. Some other way you can mark, no problem. Right. Here, you have to remember that this is a, if it is in this way, this is a polar molecule, right? Okay, actually they have to give the structure, then only we can identify, no problem. Right, this is the structure CH2, F2. If you put the fluorine other way around, this way, this, right? Okay, if it is available in this way, right? If it is available, actually this molecule is polar. I think you can understand that one. There is a attraction, this upward dipole moment develops. Here, actually it cancels, right, due to the structure. If it is one against the other, automatically the dipole moment cancels. So actually they had to provide the structure, then only we can answer. Right, no problem. Just we'll try to answer. Fluorine epidemic in this way also we can present. Okay. So this is also polar molecule, right? More chance for the polar. That we will try to answer the question. So if it is a polar, the process could be accompanied when vaporization is right. We have to remember that what is the property? What are the properties? Right. What are the properties which govern the polarization? Sorry, vaporization. Say, right, there is a molecular attraction in a liquid state. Strength of molecular attraction decide the volatility, right? Vaporization depends on the strength of molecule, strength of intermolecular attraction. If it easily evaporates, so these bonds are, we can say it is weaker. We can consider it is a weaker. So first try to think about what kind of forces are possible. If it is a polar molecule, if it is a polar, right, there is a possibility of dipole interaction. dipole interaction is possible in this case. Right, first point. Right. Okay. You mentioned a correct thing. I thought it is there are two hydrogen atoms. So sorry, I will try to rearrange the structures. Okay. Right. What you said is correct. Here, this is the structure, isn't it? Fluorine, fluorine. So definitely it is a polar molecule. We don't think about, right? I thought it is C2S, right? Right. Polar molecule, polar molecule. So, right, what initially I mentioned, okay, the polarity, sorry, volatility, evaporation depends on the intermolecular attraction. So, what kind of attraction? One is the dipole, dipole. It is polar minus plus, and in this way it can become a polar. So there is a possibility of between two molecules, isn't it? Hydrogen in a minus varum. This so there is a possibility of attract each other. So the main force is dipole dipole. There is no possibility for the hydrogen bond, isn't it? There is no possibilities for hydrogen bond. Why? The fluorine is not connected to the hydrogen. Fluorine is not connected to the hydrogen. Therefore, there is no chance for the hydrogen bond. So dipole dipole is possible. Breaking of this, right? Breaking of dispersion forces mean okay, you may know that any kind of intermolecular attraction mean London force also possible, right? Within, if there is attraction between two particles, right, particles, then there is a possibility even London force, electron cloud as there, electron cloud movement and everything is possible. Therefore, in all kind of molecules, there is a possibility of London force that we call dispersion forces. So that is possible. Second one, breaking of dipole-dipole interaction. Yes, that is the thing we discussed. Third one, you don't have a hydrogen bond, right? It is a liquid, so there is no possible liquid phase liquid. We don't have water, therefore, clearly we can say there is no hydrogen. The answer is A and B only. A and B only. That is the answer. Okay, third answer is the correct answer. Right. If you have any issues, you have to speak with me. Right. Further, question number 9. Let's start to discuss about question number 9. Which one of the following atoms in its gaseous state will liberate the largest amount of energy when it gains electron? Right. The last session also we have discussed this kind of work, right? I think we can elements are sulfur, phosphorus, sodium, and magnesium, and neon. Okay, so we have clear idea already. We have done this kind of work. Just try to remember here the elements fluorine and chlorine. Here oxygen and sulfur. Here you have to mark the phosphorus, isn't it? Here, what is that? Okay, above phosphorus, right, oxygen, you can mark carbon, silicon, and lithium, beryllium, so sodium. In this way, the things move. Here, boron and aluminium. So the place of nitrogen is somewhere here, and okay, what is that? Beryllium, magnesium shows the positive region, right? The neutral. This positive, this one positive, endothermic. This region negative, exothermic. The process is exothermic. So what are the answers, right? These are not possible. Neon is possible. It is positive. Sulfur, phosphorus, right? When you come to sulfur, that is more suitable answer, right? This should be the answer. So answer is first one, right? First is the answer. Okay. Next, we'll try to discuss the question number 10. Which of the following statement is are true, right? I think you're asking the question number 9, right? Yeah, less than 1 minute. Once again, I'll try to explain you. This particular graph I have provided to you regarding electron gaining energy, isn't it? Electron gaining energy. Okay. Which of the following atom in the gaseous state emit, right? When it gain electron, right? Gain electron, it will become in a minus, isn't it? But that process actually, what you call, sometime it will absorb, sometime it will liberate, mean emit to the surrounding. Here they ask liberation, mean exothermic reaction, exothermic. So we had to separate endothermic, exothermic. These are the two type of things shown by the elements. So